Alright guys, today we're going to talk about a literal equation. Literal equations are equations, again equations have equal signs, that deal primarily in variables. So for example, we have ym plus dc is equal to pv. And we're asked to solve for one of the variables. In this case, we're going to go ahead and solve for m. So we're going to go ahead and use those tools that we learned on our last video. And we're going to take our please, excuse, my, slash dear, and slash Sally, and we're going to flip them on their heads. And we're going to go backwards. So in order to get m, what I like to do is I kind of give it a little highlight. So I'm solving for the m. So I want to get him all by himself and move everything else. So first I have to start with that addition or that subtraction like we talked about. So my m and my y are being multiplied, but they're later down in my steps. So I have to undo that subtraction first. And since d and c have nothing to do with my m, they're going to stay together as their little pair. And again, they're added, so we're going to undo them with subtraction. So I have ym is equal to PV, because again, P and V are being multiplied, they're held together, minus that DC. And then we're going to go back and I'm going to highlight to say, okay, here's what I'm looking for. This is the guy that I'm after. How do I get him on that side by himself? Well, right now he's being multiplied with my y. So to undo multiplication, I'm going to go ahead and divide. And what I do to one side, I of course do to everything else. So m all by himself is equal to PV minus DC divided by y. Now let's think about that for a moment. Would it make sense to somehow have a numeric answer or numbers, an answer involving numbers, if I didn't have any numerics to begin with? So would you expect to have a numeric answer with no answers at all? No numbers at all? No, that doesn't make sense. That's kind of like the question, but for some reason, even though we don't have numbers, people assume there should be numbers involved, and there's not. Let's go ahead and we're going to switch our highlighter color because I like blue. We're going to look for P. So P's here is on the bottom. Okay, I need to get P by himself. Right now he's being divided, and I don't want him divided. I want them there together. So we're going to do that, undo that division with our multiplication. I'm not writing. I just am using my marker. So times P to both sides. So P on top and P on bottom cancel each other out. And don't know what my computer's doing. I'm left with VG by itself is equal to U times P. And we know that if I multiply letters, I can stick them right next to each other. And again, I say, hey, what am I looking for? I'm looking for P. He's right here. Is he by himself? No, he's not. So we got to get him by himself. And so, yes, we multiplied him, and you probably thought that was counterproductive. But if I go ahead and divide him now, I'm not going to divide by P, meaning that P is going to be in the bottom. I'm going to divide by U, since U is being multiplied with the P. So P, I don't know why it keeps wanting me to type. I'm not hitting any typey buttons. P is equal to VG divided by U. Again, I'm not hitting anything. What is this doing? My computer is spazzing out because it lost the internet, and it doesn't, I like not having no internet for some reason. There we go. So there's my two answers. And just like with my last video, I'm going to put this on my next couple slides because it's kind of important and it helps us out. All right, 3 and 4. Again, we're going to identify or highlight what we're solving for. And in this case, I'm solving for V. And he's right there. He's kind of attached to S, so I want to be really close. I didn't want to get both of them. I just want that V. Okay, he's on the denominator. When I solved my last problem, I'm going to go back for a moment. My P was the only thing on the bottom side to multiply by just that. But I have more than just one thing on the denominator. So to start this problem, I'm going to have to multiply both S and V to both sides in order to cause that denominator to disappear. Remember, denominators are just division problems, D and D. That's why they came off of each other. Okay, so my S and V are gone, so I'm left with B is equal to H first. Grr. H times S times V. And then I'm going to go back and say, okay, I'm looking for the V. There he is. He's got other stuff going on to him. And everything that he's hanging out with, they're hanging out together with multiplication. So we're going to undo that multiplication with division. And we're going to divide by everything but the V. Because we want V to stay on one side by himself. So V is equal to, those guys are gone, B divided by HS. BHS. Hey. Sorry. Little things, guys, the little things. Next problem. Again, we're going to go ahead and look at V, and he's right there in the middle. Well, right now, G and V and C are all being multiplied. And I know with multiplication, I can move stuff around to make me feel more comfortable. So I'm going to move some stuff around. I have G, C, V equals S. All I've done is flip the order. The reason being is I want G and C to be together because I want, not crayon, I want my V, I want this guy to stay right here. I don't want him to move. So what I'm going to do is I'm going to divide the guys being multiplied with him. So I'm left with just V, and he's equal to S over GC. I was like, where'd my order of operations go? Move these guys just up a smidge. Alrighty, let's go ahead and start by looking at what we're looking for. We're looking for R. Right now, R is being multiplied by T. Well, that's pretty simple. If they're just stuck together, that's multiplication. And we know we undo multiplication with division. And what I do to one side, I have to do to the other. So R is simply equal to D over T. I hear you use some of these letters in some science classes. Maybe Mrs. Seibert's. All right, next one. We need 4T, and T is right now being multiplied by 5. Hey, look, this is our very first problem that has numbers. So because it has numbers, we should think that later on, my answer should have some numbers. So let's try it. Will it all be numbers? No. Will it be one solid number? Absolutely not. It's going to be consistent with what we've been doing. Now, we've got multiplication, we've got subtraction, we got some more multiplication. So, since the 5 is affecting my T, I need to keep them together because I have to get them by themselves in order to separate them. However, I've got this extra junk going on. And that extra junk falls under this first category of undoing my addition and subtraction. So, before I can get to that T, I need to undo that subtraction, and I'm going to add them over. And again, we have to make sure we're thinking logical. My 25 is a constant. Can I put a constant together with a variable? No. So 25 comes down plus 2R. They do not magically make 27R, but 25 does not have a variable. He's a constant. You do not get to put them together. All right, let's go back. Have I isolated my variable? Is my letter all by itself on one side? Is he? Nope. So we're not done. Well, in order to get the t by himself, he's right now being multiplied. Undo multiplication. Simply use division. So now they're gone. I have t is equal to 25 plus 2r, all divided by 5. Is t by himself? Yes, he is. So we get a good old circle. I think these are our last two. All right, let's go ahead and try them. Let's go ahead and identify what letter we're doing. We're going to solve for B, and B's on top here with my H. Okay. Now, no, that must be a homework problem. Something I want to make note of because I believe it's in your homework. Capitals and lowercase are different. So for example, if you had two A's, like you had a big A and a little a, or you had a big B and a little b, or you had some kind of a letter combination where you've got a capital and a lowercase of the same letter, they are different. You don't get to combine them. So I want to make that note. I think it's in the homework that it does this. Don't ask me which one. I'm 99.9% sure there's one in the homework where it's got the same letter. There's an uppercase and a lowercase. They are not the same. You don't get to put them together as 2B or 2A. It would be capital B plus little b. But again, a note for another day. So let's go ahead and go back to our first problem that we were starting. A is equal to B times H divided by 2. I hear this might be the formula for a triangle. Just saying. I have my B on top of my numerator, so I need to get it all by himself, but he's got this division of 2. So before I can start the problem, I have to get rid of that division. And we know we can undo division with multiplication. So I have 2A, big capital A, is equal to B times H. All right, let's go ahead and get our identifier. Is my B by itself? Nope, he's not. He's still there. So in order to undo him, he's being multiplied. So I have to divide. That causes them to cancel. B is equal to 2A over H. Circle it. All right, last one. We're going to go ahead and look for W, and W is here in the middle. And I see that, again, W is just being multiplied by everything. So just for the sake of it, because I like to make sure that I'm following proper directions, I'm going to rewrite it so that my W comes later and I can just move other stuff around. And again, we can move other stuff around as long as we just flip it to the other side if it is multiplication. So I see multiplying, everything's being multiplied together. So to undo multiplication, I'm going to go ahead and divide. And what I do to one side, I do to the other. And yes, I write part cursive. That's why I try and type stuff. No one likes my handwriting. So W is equal to big capital V divided by L, H. Woohoo! You survived literal equations! Woo!